To see Canada from the air is to be gripped by the magnitude of opportunity. Here is an area larger than 90% of the Earth's other nations. A land brimming with resources, natural treasures that could never be brought to their full potential were it not for one vital link. That link is lubricant, the lifeblood of the heavy equipment that enables Canadians to make the most of our natural resources year-round. Making the right choice in lubricant would be critical in any country at any time of year. But in Canada, choosing the right cold weather lubricant is imperative. That single decision could ultimately mean the difference between profit and loss, between prosperity or failure, between a vibrant, thriving place to work and nothing. Look closely now. You're about to meet one of your Cold War enemies. These are wax crystals. Wax is a key component in the base oil that goes into the vast majority of today's lubricants. This computer animation represents a single molecule of wax. As the temperature drops, wax molecules nest together, a little like stacking lawn chairs. In this formation, oil molecules get trapped between the wax, and everything sets up into a semi-solid mass that can render even the most powerful equipment helpless and immobile. Dealing with wax is just one of the challenges lubricant makers must address when they blend their products for winter performance. It's just one of the reasons some lubes have better fluidity than others. In this research cold room, 5 grades of heavy-duty engine oil have been chilled overnight, all the way down to 35 below zero. As this demonstration suggests, at minus 35, the fluidity of these 5 oils is very different indeed. Now, what do these differences mean to you and your equipment? Well, there are really 3 key points to remember about winter lubrication and what it can mean to your performance. Start up quickly. Warm up safely. Stand up to operating temperatures. The first of these key points is that the right lube will have the fluidity to help you to start up quickly. That fluidity will also allow your equipment to warm up safely. Yet for all that fluidity, once the equipment's up and running, the right lube will now undergo an almost magical transformation. It will now have enough body to stand up to the demands of full operating temperature. Let's see what's involved in a typical cold weather startup. Here are 2 heavy-duty engine oils. The temperature in our cold room is once again 35 below. The oil on the left is a synthetic blend 0W30. This is a 15W40. Normally a fine choice of multigrade, but at minus 35 Celsius, the oil is just too thick to enable the engine to turn over and fire. Anyone who has ever heard that sound, and is there a Canadian who hasn't heard it at one time or another, knows the importance of being able to start up in the cold. When outdoor equipment fails to start, it can do a lot of damage to a production schedule. And it's not too much fun for your equipment. To give you an idea of what we mean, we brought some passenger cars into Imperial Oil's cold weather test facility, where we'll be able to see just what's involved in a startup at minus 35 Celsius. To get a better look, we took off a few parts of the engine. Keep in mind, that although this is a passenger vehicle with a gasoline engine, the principle holds true for any kind of equipment you may be running in the cold.
Exhaust is on, and crank.
Key on.
The oil in this engine is a 0W30 synthetic blend, and it does exactly what you'd like an engine oil to do in a grader, bulldozer, or tree harvester at 35 below. It starts up quickly. The engine started quickly, but just as important, the oil began to flow almost instantaneously. Exactly what you want in a safe winter warm-up. Still, if we take another look, we'll see that the oil appears first at cam tower number 1, then at number 2, number 3, and finally number 4. When you're getting a good flow of oil, that small difference in lubrication time is negligible. But now, let's see what happens in a more typical situation. This time, the oil is at 10W30, the grade still used by most Canadian drivers. Once again, although we're looking at a passenger car, the principles hold true for your heavy equipment come winter. In a test facility like this, with lots of spare parts nearby, we're able to keep on cranking away just to make a point. In real life, of course, you'd never crank for more than 30 seconds straight, since despite the extreme cold, that action could melt the solder in your starter and burn it out. 35 seconds after we start cranking, the first oil appears at the cam tower. Does that cloudy quality look a little familiar? You're right, that's wax in action, or more accurately, keeping any action from taking place. With 10W30, it took 1 minute and 10 seconds of cranking or chopping up that heavy oil before the engine could get up enough RPM to start. That's over 1 minute of metal-to-metal contact. Now, at this point, many operators would breathe a sigh of relief and get on with the job. The engine's up and running, so we're ready for the cold, right? Well, let's take another look at those 3 key points. Start up quickly. Warm up safely. Stand up to operating temperatures. After the startup, the right lubricant will enable your equipment to warm up safely. How important is this? Let's take a look. We're going to see another demonstration at -35 Celsius to show what can happen in the warm-up stage when you've made a wrong choice in engine oil. This is a sump or oil pan from a heavy-duty truck, the place where engine oil lives through those long winter nights. If the right oil is used, it will quickly pump up from the oil pan and into your engine where it belongs. But now, let's see what happens with the wrong engine oil. Until the engine warms up and the oil reaches a temperature at which it can properly flow, there'll be parts of the engine that are literally starved for oil. Other parts will receive a mixture of oil and air bubbles, and as we all know, air in any form is not a lubricant. Let's see it again, and keep in mind that what you're viewing could all take place without the driver having any idea about what's going on.